Good morning. Let's do some examples of related rates problems from section 2.7. Forgive me for wearing my hat. I'm in my classroom and it is freezing in here. So yesterday's video introduced related rates. So we are taking derivatives of functions with respect to time. And the assignment from yesterday just gave you equations like regular old y equals x squared plus 3 or equations with x and y, and you took derivatives with respect to time. And then you substituted in some given information and solved for either dx dt or dy dt. The goal of those examples was just to get comfortable with the process of taking derivatives of function with respect to time. The real use for this is in real life problems, as these three examples will show. So the equations aren't necessarily going to have x's and y's in them. But as with yesterday, the equations are not going to have a t in them, but we're still going to take the derivative with respect to time. So this video just has three examples, and then your homework assignment has 4 problems, and there will be, I think, 2 more versions of a couple more examples followed by a couple more problems. Because it's kind of almost a limitless, that was a calculus pun, number of contexts that could show up here. So here's the overall process of how to solve one of these related rates problems. And we did much of this the other day in the other video. Number 1 says identify all given quantities and quantities to be determined. Make and label a sketch. So, like if it gives you the dx dt equals 10, or it gives you that when y equals 4, find dx dt's. Just make sure it's real clear what they're giving you, what they're finding. In particular, the rates that they're giving you. Like yesterday's assignment said, given dx dt equals 7. Well, in these problems, it's not going to word it like that. It's going to be a word problem. The something is changing at a rate of 5 something per something. You have to read that as, oh, that's dr dt or dA dt. So you have to be able to decipher the word problem. So, and make a sketch if at all possible. Sometimes the problem, one of these 3 problems comes with a sketch. The other one just helpful to make one. Number 2 is the step we didn't have to do yesterday. Step 2 says to write an equation that involves all these variables. So the problem is not going to give you the equation. It's going to be talking about the area of a circle, or maybe the sides of a triangle, or maybe the volume of a cylinder. Like, you'll have to, from the context of the problem, figure out what equation there is that relates the variables that they're giving you and that they're asking about. So that's really the only difference here. So we're going to figure out what equation to use. From here, it's the same. Step 3 says use the chain rule. Take the derivative with respect to time. Remember, that means that every variable is going to have a d whatever dt attached to it. And then at the end, we are going to still substitute in the quantities that were given and solve for the quantity or the rate that we're being asked for. So much of this process hasn't changed. Now there's just a context. So again, I've got 3 examples. Let's see if we can't get through these in a reasonable amount of time. All right, example 1. It says a pebble is dropped into a calm pond, causing ripples in the form of concentric circles. So you drop a pond in the water, and the circles slowly get bigger. We're worried about the outer circle. It says the radius r of the outer ripple is increasing at a constant rate of 1 foot per second. When the radius is 4, at what rate is the total area of the disturbed water changing? So we have to turn those sentences into some equations or some mathematical statements. Let me highlight this. The radius r is increasing at a constant rate of 1 foot per second. The radius r is increasing. That's the rate of change. You have to read that as dr dt equals 1. Like that, the radius is increasing. So that's what that thing says in yellow. And then it says, I go back here. It says when r is 4, at what rate is the area changing? So what is that asking for? That says when r equals 4, when the radius is 4, at what rate is the total area changing? It's asking us to find how fast the area is changing, dA dt. So you have to be able to read a problem like that and figure out, okay, this problem gave us a rate, dr dt. That's how fast the radius is increasing of that outer circle. And then at the very moment when r happens to be 4, how fast is the area changing? So that's So there's the equations, or there's the given information and the quantities we're trying to find. Now it said we have to write an equation. So I need an equation that somehow relates the area of a circle and the radius of a circle. Well, you learned in a geometry class, and probably several years before that, the area of a circle is in fact pi r squared. That is now the equation we're going to take the derivative of with respect to time. So again, we had to figure out what the equation is. In this case, area and radius of a circle. So now let's take the derivative. Let's use the chain rule and use implicit differentiation to take the derivative of this equation with respect to time. So the derivative of a with respect to time, that's just dA dt. And the derivative of pi r squared, remember pi is just a number. It's not a variable. We don't have to use the product rule on this right side. Pi is just a number, so I can move the 2 out front. It becomes 2 pi, and then r to the first power, and then times dr dt. We took the derivative of this function with respect to time and get that thing out of there. Okay. Now, let me back up for a second. We'll go back to the equation that I took the derivative of. A normal question that people ask is, why didn't I put 4 in there for r? Like it gave us when r is 4. But what you have to recognize, and you'll see this in all of these problems, the quantity r, as that circle is expanding, that quantity is changing. And if it's changing, you have to leave it a variable. After you take the derivative, which we've now done, now we're going to plug in the given value of 4. So it would be wrong, but very tempting to think, okay, is my formula a equals pi times 4 squared? Like, should I have started with that equation and then taken the derivative? And the answer is no. Again, that 4 needs to be a variable still. When it says when r equals 4, this information here, we don't need that till after we take the derivative. So we took the derivative, we got dA dt equals 2 pi r dr dt. Now let's, in fact, I can extend the page here, there we go. Now let's plug in the given information and solve for what it's asking for. This particular question was asking for dA dt. So dA dt equals 2 times pi times, now the radius, it said when r equals 4, that's where the 4 goes. And this question also gave us dr dt. If I scroll back up here, dr dt was 1. So I plug in 1, and I get, what's that, 8 pi? The answer is dA dt equals 8 pi. And then I'm going to be fairly picky. Make sure you can, if needed, make sure you can, if needed, give the units. And dA dt, that would be a unit of area over a unit of time. Area would be, what is it, feet squared per second. So an area unit would be feet squared, so it'd be feet squared per second. And just so you know, my test or the AP test sometimes will say, find the rate in feet squared per second that the area is changing. And if it gives you the units, you wouldn't have to put the unit. But sometimes it'll say, find the rate, and it'll say, include units. So just be aware of, if it's not there, it might ask for it. If it asks for it, make sure you give it. So there's your first example. We turned the question into a bunch of rates and information given, desired. We figured out what equation to use. We took the derivative of it with respect to time, and then we substituted in the stuff that we were given, and we solved for what it asked for. So that's one example. Got 2 more. All right. Air is being pumped into a spherical balloon at a rate of 4.5 cubic feet per minute. Find the rate of change of the radius when the radius is 1 foot. So again, we have to turn all of that question into, what is it telling us? Air is being pumped into a spherical balloon at a rate of 4.5 cubic feet per minute. That is how fast the volume of the balloon is changing. That's not the rate, that's the amount of air. That's a 3-dimensional. So that's telling you how fast the volume of this spherical balloon is changing. So that tells me that dV dt equals 4.5. That's what that blue sentence tells me. Now it says, I meant to change colors. That's going to become green, sorry. Find the rate of change of the radius. So we want to find the rate of change of the radius. That's how fast the radius is changing. That's dr dt. Find dr dt when the radius is 1 foot, when r equals 1. I would argue that what I just wrote in my blue and black marker, if it would have been given to you like that, it kind of looks like the problems you did yesterday, questions 1 through 4, where it said dx dt equals this. Find dy dt when x equals, like that's kind of how that format was. So now, again, what was new here is I have to find, determine, figure out an equation that results volume and radius of a sphere. There are some geometry formulas you kind of need to remember. The volume of a sphere is one of them. And the volume of a sphere, if you don't remember, I'm going to tell you, is 4/3 pi r cubed. Let me separate the information there. That is the formula for the volume of a sphere. So that's the equation that we're going to take the derivative of with respect to time. So let's do that. The derivative of v would just be dv dt. And now, again, 4/3 is a constant and pi is a constant. If I move the exponent 3 out front, 3 times 4/3 happens to be 4. So I get 4 pi r squared. Then I need that dr dt at the end. So there is the derivative of that equation with respect to time. And now I think I can substitute in the information that I have and solve for the desired rate. So this time it gave me dv dt. It said it was 4.5 equals 4 times pi times something squared. The radius, it said when r equals 1. And then times dr dt, which is what this question wants me to solve for. So now let's be careful how this might look when we're done. Now, on the AP test, it's if it's a multiple choice test, the answers would probably just still have a pi as pi. You certainly could decimalize it and make it a decimal. I'm going to leave the pi as a pi. And if it were on the extended response, if it said to the nearest thousandth, then you would decimalize it. Otherwise, you can leave it in pi. So this becomes what? 4.5. That's not much to that. Equals 4 pi, 1 squared is just 1, times dr dt. And I divide both sides by 4 pi. And I get dr dt. Let's be careful how I might write this. Equals 4.5 over 4 pi. Couple things. Make sure it's clear that in this particular case, the pi is in the denominator. It does not say this. It's not 4.5 over 4 pi. It's 4.5 over 4 pi. Now, that's just a big fraction right there. Nothing wrong with leaving it like that, although you rarely see a decimal on top of a in the middle of a fraction. So if I doubled the top and the bottom, I'd get 9 over 8 pi. I might leave it like that. Dr. Again, I could certainly decimalize it. And what would the unit be? This is the rate of change of the, what was I finding? Radius. And radius is just a one-dimensional, what is that, feet? So that would be feet per minute. The unit would be feet per minute. And again, it turns out to be 0.358 if you want to make that a decimal. And then a reminder, the AP test, if you're making it a decimal, the AP test requires 3 decimal places. Either rounded or just truncated, so that either one of those is fine. But it's got to be, for some reason, the AP Calc test is very picky. If you're decimalizing things, 3 decimal places. So 0.358 feet per minute. That's how fast the radius is changing at the point where the radius is 1, if the volume is changing at a rate of 4.5. So there's your second example. One more. This one comes with a picture. I even found some glorious clip art. Okay, an airplane is flying on a flight path that will take it directly over a radar tracking station. So there's the state, there's the building. The plane was directly over it. Now it's flying away from it. The distance S, I think I typed it in wrong. Let me make sure it's right. So okay, I've got this backwards. Sorry. It's no, I've got the problem. I apologize. It says the distance is decreased. This plane is actually flying this way. I labeled my picture wrong. And the plane, I should rotate the plane, but I don't know how to do that with my art. So please have the plane going that way. Sorry, I should have reflected my picture. The plane's flying that way. So it's flying where eventually it's going to be right over this tracking station. It says the distance S, which is the distance from the tracking station to the plane, is decreasing at a rate of 400 miles per hour when S equals 10. So distance S is decreasing. So that means that is ds dt. And since that distance is decreasing, this would be negative 400. Got to be real careful. If a quantity is getting smaller, then the rate of change can be negative. And then it says when S equals 10. And what does it want? It wants the speed of the plane. Well, that's just how fast it's traveling in this direction. This quantity is x. So it wants us to find dx dt. Now, let me before I start and go any further, notice as the plane is flying in this direction, that x is decreasing, like that distance until it gets over the tracking station. It's going to be decreasing. But remember, speed, which is what the question is asking, is the absolute value of the velocity. So dx dt, I think, is going to be a negative number here when we're all said and done. But that's not this. The speed is just going to be the absolute value. So you'd lose part of the credit if your final answer was negative. That would be the velocity of the plane, given that x. So just be aware of that. So now I think I labeled my picture. I identified what quantities it gave us and what quantities it is asking for. I need an equation that relates. In this case, I've got the three sides of a right triangle. It told us that we're 6 miles off the ground there. So whenever you see three sides of a right triangle, you need to think Pythagorean theorem. So my formula is going to be a squared plus b squared equals c squared. Now, those aren't the right variables. So now let's talk about, in our picture, a squared plus b squared equals c squared. I've got 6, that's one of my sides, and then I've got x, and then I've got s. So I think my equation is 6 squared plus x squared equals s squared. Now, your question, again, if you were sitting in my classroom, would be, why did I use 6? But you'll notice I did not use 10. I used s. And I come back to what I said 5 minutes ago, which is if a quantity is changing throughout the problem, leave it as a variable. And that distance s, as the plane flies, that distance is changing. 6 miles, that's the altitude of the plane. As the plane flies straight across, that's not changing. So that can be a number. That's why that 6 is a 6, but the s is in fact a variable. So there's the equation I need to take the derivative of with respect to time. Well, don't get fooled. 6 squared is just 36. 36 is just a number, and the derivative of a number is 0. So don't put 2 times 6 to the first. It's not a power rule. It's a constant. So that's just 0. The derivative of x squared is 2x dx dt. And the derivative of s squared is 2s ds dt. And now, can I substitute in what they gave me and solve what they asked for? Let me remember, what am I trying to find? I'm trying to find the x dt. So let me highlight this. That is what I'm trying to solve for. So can I, and something shows up here that we haven't seen yet, I want to plug in quantities for the other unknowns so I can solve for that. So it's 2, that's a 2, times something times dx dt equals 2 times something times something. Those are all those parentheses I need numbers for. Well, the s, I think it said when s was 10, right? Let me go back here. When s is 10, so that becomes 10. And then the ds dt, I think it also told us, didn't it? ds dt was negative 400. But I don't, it appears that's supposed to be a negative sign. I don't have an x. Like, let me draw this up here again. At is my right triangle. At the moment when that is 10, that is always 6. The question is, what is x? Like, we're actually going to have to go back and use the Pythagorean theorem. That quantity s is changing. But at the moment when it's 10, we can figure out x. So this just becomes 6 squared plus x squared equals 10 squared, which is 36 plus x squared equals 100. Maybe you recognize it's a 3, 4, 5 multiple here. You get x squared equals 64. X turns out to equal 8. So there's an example where one of the quantities we needed to substitute in appeared to be missing, but we actually could go back and find it. So that becomes 8. Now let's just do the arithmetic to solve this for dx dt. That becomes 16 dx dt equals, I think it's negative 8,000. Let's see, negative 800 times 10. I divide both sides by 16. I think it's negative 500 maybe. Now, negative 500. But since the question asked for speed, you have to remember that speed is the absolute value of velocity. So the speed, again, you would get practically full credit, but if you put negative, that's not the speed. 500 miles per hour. There's the speed of the plane. And I almost made it before my lights turned off again, but I didn't. So there's the 3 examples. And your homework assignment is just 4 problems. And like I said, tomorrow there'll be another video with 2 or 3 more examples. The next day, 2 or 3 more examples. Just because there's so many different contexts, I want to expose you to an example before I ask you to do a problem. So that is it. You have any questions? Again, don't hesitate to reach out. Otherwise, have a great Tuesday.